When the moon falls into Earth's shadow on the night of March 13th to 14th, observers will witness a blood moon, total lunar eclipse. However, for solar-powered spacecraft on or around the moon, this event presents a significant challenge. NASA's Lunar Reconnaissance Orbiter, LRO, which has been in orbit since 2009, will take precautions to endure the extended period of darkness. During the eclipse, LRO's science instruments and non-essential components will be powered off to conserve energy. The spacecraft relies on solar panels to charge its battery during the daylight portion of its 2-hour orbit, using stored energy while on the night side. Over the years, its battery efficiency has declined to 70%, making energy conservation critical. As the total lunar eclipse will last for nearly 6 hours, careful planning is required to ensure LRO's survival. Enjoying the video? Don't forget to subscribe and hit the bell icon to stay updated with our latest content. Before entering the eclipse, the spacecraft's battery will be fully charged, and to minimize power consumption, all scientific instruments will be switched off. Darkness also causes a drop in temperature, so LRO's instruments and spacecraft will be heated beforehand, reducing the need for additional power during the eclipse while keeping components within safe operating limits. Previous eclipses allowed for some scientific observations, such as keeping the Diviner radiometer active to study how the lunar surface cools in Earth's shadow. These measurements have provided insights into the composition and structure of the lunar regolith. During the total lunar eclipse on October 8, 2014, Diviner observed the Kepler crater and a lunar nighttime cold spot, revealing complex thermal behavior that suggested variations in regolith layering. LRO is not the only active lunar mission affected by the eclipse. Firefly Aerospace's Blue Ghost lander, which arrived in Mare Crisium on March 2nd as part of NASA's Commercial Lunar Payload Services program, also relies on solar power. The lander was designed to function only during the lunar daytime, roughly 2 weeks long, after which it is expected to succumb to the extreme cold of lunar night. Sunset at Blue Ghost's landing site is expected on March 16th, but the eclipse will plunge it into shadow 2 days earlier. The lander's batteries can sustain it for several hours without sunlight, and although the total duration of the eclipse is over 6 hours, only 65 minutes will be in complete darkness under Earth's umbral shadow. Confident in the lander's resilience, the Firefly Aerospace team plans to capture high-resolution images of the eclipse from the lunar surface, effectively witnessing a total solar eclipse from the moon's perspective. As the eclipse unfolds, while observers on Earth marvel at the celestial display, the spacecraft on and around the moon will navigate a harsh and unforgiving environment, relying on meticulous preparation to survive the prolonged darkness.